Hello. Yeah, welcome back to Apostle One Tutorials. Now, we are still going to continue with the circuit theorem, but please don't forget to subscribe to the channel and then share to your friends. Yes, it's very beneficial. Now, let's see the cyclic quadrilateral. Property 2, our second property on circuit theorem. Okay, now let's see the property. I call the property the cyclic quadrilateral. Now let's see the opposite angle. Okay, now let's see the opposite angles of a cyclic quadrilateral are supplementary. You know supplementary angles. When you say supplementary angles that add up to 180 degrees. So that is the angle supposed to add up to 180 degrees. Now what does it mean? What does it mean? So when you say quadrilateral, you know quadrilateral is any plane figure bonded with, or any polygon bonded with four sides. So it can be in any shape. This one is a quadrilateral. This one is a quadrilateral. Quadrilateral can be like this. Can be like this. Like any shape. It's supposed to be bonded with four sides. So when we find this quadrilateral in a circle, when quadrilateral is inscribed in a circle, we call it cyclic quadrilateral. When quadrilateral is inside a circle, we call it cyclic quadrilateral. So the property is saying that when we have a circle and there is a quadrilateral inside a circle. Now this one is quadrilateral inside a circle. It touches, the vertices touches the circumference of a circle. So let's say this one is A, B, C, and then D. The angle here, let's say the angle here is A, the angle here is B, the angle here is C, and the angle here is what? D. This angle, this angle, this angle, and this angle. What are we saying? Opposite angles. Which angles are opposite? This one is opposite to this one, and this angle is also opposite to this one. So the opposite angle are supplementary. It means that when we add the opposite angle, it's supposed to give us 180 degrees. Yes. And which ones are the opposite? A and then C, they are opposite angles. So A plus C is supposed to give us 180 degrees. And then B and D are also opposite angles. So therefore, B plus D will give us 180 degrees. But you remember that in our introduction to plane geometry, we talk about quadrilateral, where the sum of an interior angle of a quadrilateral is 360 degrees. And this one proved that it is 360 degrees. So when we add A plus B plus C plus D, when we add all of them, it's supposed to give us 360. So we have A plus B plus C plus D is supposed to give us 360. So we are adding all, just like 180 plus 180, which will give us 360 degrees. So this is the cyclic quadrilateral we are talking about. The opposite angle is supposed to add up to 180 degrees. Don't forget. So when you see, look at it very well. The vertices of the quadrilateral is touching the circumference of a circle. Note this one. Look at this. The vertices, this one is also a quadrilateral. So you can meet a question like this. This one is also a quadrilateral. Because we have this one, this, and this, and this. And then it touches the vertices at this point, and then this point. So it's also a quadrilateral. It can be in so many forms. You have to be able to identify quadrilateral in a circle. But note this particular thing is not a quadrilateral. Look at this. So if I have something like this, and then they say this one forms an angle here. This one can never be a quadrilateral, right? This one is not a quadrilateral. But we can add this one. Look at this. This one is not quadrilateral, but when we add this one, look at this. This one is touching, this one is touching, this one is touching, this one is touching. So this one becomes a quadrilateral. The bigger one becomes a quadrilateral. You have to be able to identify them in a circle. So this side and this side is supposed to add up to 180. This angle and this angle is supposed to add up to 180 degrees. This is the quadrilateral we are talking about. This is the quadrilateral we are talking about. Yes. Now, so you can make some simple questions like you can have circle like this where this angle is 40 degrees. Here is M. Here is 50 degrees. Here is N. We can easily find the value of M and N. It's a cyclic quadrilateral. Touches the circumference of a circle. So we can say that the M plus 50 is supposed to give us 180 degrees. So N will give us what? Here plus here will give us 180 because they are opposite angles. So we have N give us 180 minus 50. N will give us what? 130 degrees. We can also talk about this one and this one giving us another 180 degrees because they are opposite angles. So M plus 40 is equals to 180 degrees. We have M is equals to 180 degrees minus what? 40. And this one will give us 140 degrees. We can talk about many examples. Now let me talk about this example too. Now we are still on the cyclic quadrilateral. Cyclic quadrilateral. They can also confuse you in so many ways. Now I can have something like this, then something like this. Now let me consider this angle to be 110 degrees. Here is M and here is, let's say, 60 degrees. This side is N. Now, so how can we get the value of M and N? So let's look at this. It's a cyclic quadrilateral. Why? This one touches the circumference of a circle. It touches this point. It touches here, touches here. So it touches 4 points at the circumference of a circle, but just that this line has been extended. This line has been extended. Now listen. So in a simple term, I can say that I can find the value of M. So this and this are opposite angle. Here and here, they are opposite angle. And opposite angle add up to 180 degrees per our cyclic quadrilateral rule. So we have M plus 60 equal to 180 degrees. Our M will give us what? 180 minus 60. Our M will give us 120 degrees. Now, how are we going to find the value of N? Okay, now this one is a straight line. This angle and this angle are angles on a straight line. So therefore, remember our previous video, we said that angles on the straight line add up to 180 degrees. Yes, so since this one and this one, they are angles on a straight line, then we can say that 110 plus here is supposed to give us 180 degrees. So we can easily subtract 110 from 180. So this side will be what? 70, because they are angles on a straight line. Right? Then we come back to here and here are quadrilateral. So therefore, they form opposite. They are opposite angles. So they form an angle of 180 degrees. So let's add them. We have N plus 70 is equals to 180 degrees. So N is equals to 180 minus 70. N is equal to 110 degrees. Oh wow, we are still getting 110. Then we can draw another conclusion from the quadrilateral, from the cyclic quadrilateral. Per this one, here the angle formed outside here, that is the exterior angle here. Can you say the exterior angle here is 180, and we are getting the N to be 110. We are getting the N also to be 110. Then why is it that previously we didn't say that this side is equal to this side? Then we can put that rule in our mind too. We can put that rule in our mind that when we have a quadrilateral where one length is being extended, example like this, So this one forms an angle here, and angle here. And this one is being the angle being extended. We can also draw this conclusion that since the extended part here is 110 and then the end here is also 110, we can say that always the extended side is also equal to this side. I hope we can make that conclusion when it is a quadrilateral. Yeah, we solved it and we had the same answer because we're always looking for a simple way we can get to the answers. Yes, so we can say that this side and this side will give us 180. So therefore here, just like here plus here will give us 180 angles on a straight line. Here plus here is supposed to give us another 180 angles on what? On a straight line. So here plus here will give us 180. The same as here plus here will also give us 180. But don't forget that when it is extended, this one is not tangent. When a cyclic quadrilateral, one side is being extended to form an exterior angle. The angle formed at the outside the cyclic quadrilateral is the same as this angle inside. This angle inside, we can draw that conclusion. So this one is just simple understanding. You have to know in the cyclic quadrilateral, that's when you have an angle inside a quadrilateral inside a circle, inscribed in a circle or inside a circle. The opposite angles add up to 180 degrees. So you'll be seeing these things in the question as we are moving on. So we are going to end here. Then we take more questions on cyclic quadrilateral in our next video. Don't forget to subscribe to our channel. Then press the notification bell. Turn it on so that whenever I upload the next video, you'll be the first person to get it. See you in the next video. Bye bye.